Hey everybody, it's Mr. Carr again. Today we're going to be looking at 10 to day one. We're going to continue talking about sequences, but today we're going to talk about a very specific type of sequence. Okay, so before we talked about what are sequences with our patterns of numbers. Now we're going to be talking about arithmetic sequences, very specific type. Okay, so let's look at this sequence of numbers that is an example of an arithmetic. It says you determine the common difference in the next four terms of the arithmetic sequence. So the common difference is telling us what number we are either adding or subtracting as we go through the pattern. So for example, here, if we go from negative 53 to negative 36, that is adding 17. If you watch that pattern here, we're still adding 17. So when we do this, another way we can always say this, we look at the terms idea. The common difference is always going to be the difference between, whoops, wrong thing there, the difference between a term and the term right before it. So it doesn't matter where we do it, it's always going to be subtracting the two terms. So for example, if I did negative 36 minus a negative 53, that would come out as a positive 17. And that's what we're having here. So in this case, my common difference is 17. So just keep in mind, you don't have to use this as its own formula. But if you're having trouble determining what it is, always just take this minus the previous one, or this one minus the previous one. It doesn't matter. That's what I'm saying here. Any term minus the previous term. So the next four terms, we're just going to continue the pattern on now. So we can do negative 19 plus 17 is going to give me a negative 2. Negative 2 plus 17 is going to give me 15. 15 plus 17 is going to give me 32. And 32 plus 17 is going to give me 49. So those are my next four terms in this sequence. So whenever you add or subtract by a constant number, that is creating an arithmetic sequence. We can model that with its own kind of a rule. So the nth term of an arithmetic sequence, and when we say nth term, what we mean is this a sub n, okay, is always equal to the first term, a sub 1, and with the common difference of d, it looks like this. It's a sub 1 plus n minus 1 times d. So you can see this here, like we don't have the explicit rule written yet. So remember, I should say that too. This is called the explicit rule. This is basically a formula where you can plug in any value you want for n, and I'll tell you what number is in that spot in the sequence. So here's like a sub 1, a sub 2, a sub 3, and so on. So if I look at it, I'm trying to analyze a sub n here. We want the first term. So in this case, it's going to be 2 plus we have n minus 1 times the common difference. The common difference here is plus 3 plus 3. So I'll leave a times 3 here. That's it for the explicit rule. Now there is a slightly different way I can write that. Because of this, I could distribute the 3 here. So a sub n is equal to 2 plus, it'll be 3 times n minus 3. Combine these together so that a sub n is equal to negative 1 plus 3n. This is a slightly different way to write it. If it makes it easier for you to understand it, great, but you don't have to do it that way. Now, in this mini example here, the 16th term, which is a sub 16, will be found by doing this formula here. You can take 16 minus 1, okay? 16 minus 1 is 15, times 3 is 45, plus 2 is 47. So the idea is that if you continue this pattern on and on and on, in the 16th spot, it's the number 47 there. So that's the explicit rule, okay? And again, if you do that here, if I put 16 here, that's 3 times 16 is 48. 48 minus 1 is 47, okay? So the idea is that this formula will tell us any spot we want in the sequence. So in order to model that, we need a first term and a common difference. That's it. So we look at this one, we're going to write the explicit formula and a recursive formula, which we'll come back to in a minute here, for the nth term of this arithmetic sequence. So first thing I'm going to do is a sub 1 is 14. I know that. The second thing I want to do is, what's my common difference? So how do I get from 14 down to 3? So I asked the question, how do I get from 14 down to 3? Let me just scoot this down a little bit here. So 14 down to 3, that's minus 11. Does that pattern continue? Yes, it does. 3 minus 11 is negative 8. So my common difference here is a negative 11. So I can just plug everything I need to into this formula. So a sub 1 plus n minus 1 times d. So any term in the sequence is equal to the first term 14 plus n minus 1 times a negative 11. So that's my formula. So again, if I needed a specific spot, like the 10th or 20th or whatever term in the sequence, we can plug it in there. The recursive formula is going to be, if you remember from before, recursive means we're going to refer to previous terms in the sequence. So every arithmetic sequence, when it's written as a recursive relationship, is going to look like this. Since we are only taking the previous term and adding or subtracting by a common difference, any term in the sequence is equal to the previous term plus the common difference. That's it. But we also want to make sure we state what is the first term. So we say a sub 1 is equal to something. So every arithmetic recursive formula looks like this, because arithmetic is just adding or subtracting the same number for the pattern. So in this specific case, we're going to leave it as a sub n minus 1, but then I'm going to write minus 11. Okay, make that look like a little bit closer to a sub n minus 1. Okay, and then my first term is 14. That's it. So we're just filling in that common difference number that goes into that recursive formula. And again, what it is stating is a term in the sequence is equal to the previous term subtracted by 11. That's what it means by recursive. So let's find the 41st term of this arithmetic sequence. Now, technically speaking, I could, if I got 1, 2, 3, 4, I got 4 terms in. If I analyze the pattern, which in this case is minus 7 as I go through, okay, I could, if I really wanted to, just keep going, minus 7, minus 7, minus 7. That's going to be a while. That's a lot of work that we're doing in that case. And it might be tough to keep track of that. So the goal here is let's model this with an explicit rule, and then we can just plug in 41 for our n. So again, we have a sub 1 is 11. Common difference is negative 7. So my sequence is equal to 11 plus n minus 1 times a negative 7. From here, we want the 41st term. So that is a sub 41. So now we're just going to plug in the 41 in for n, and then we can calculate this out. Okay, so 41 minus 1 times a negative 7. So a sub 41 is equal to 11 plus 40 times a negative 7. We'll do our multiplication first. So that's going to be a negative 280. And then we can combine that with 11. So we get a negative 269 for my 41st term. Okay. So again, to find a very specific one, especially a large term or like a very far spot into the sequence, we want to first model it with an explicit rule, and then we can just plug in the 41 and calculate it out. Okay. On the first term of the arithmetic sequence for this one. So based on what's given, I know the common difference, I know the 44th term. So let's go back to that explicit rule, and let's start filling in what we know and what we don't know. Okay. So we know common difference is 8. That can go there. A sub 44 can go in this spot. It's a term that's in the sequence. We don't know this one, but we do know this one now. We know that n is going to be 44 in this specific case. So what I can do is I could take 229, replace the a sub n, because that's going to take the spot of a sub 44. And that's going to equal to the first term, which we don't know, plus 44 minus 1, times a common difference of 8. So now it's just a matter of multiplying through and solving out. There's not a lot to do here, because I'll have 229 is equal to a sub 1 plus 43 times 8. Okay, so we got 43 times 8 gives me 344. And then we'll subtract that to the other side. And I got a negative 115 for my a sub 1. Now, this problem didn't ask for it, but I could, if I wanted to, now write this out as an explicit rule. I have a sub 1, I have the common difference. We could just put that in if we wanted to. All right. Our last example is going to be covering what's called arithmetic means. In an arithmetic sequence, I know that 6.2 and negative 1.6, this is telling us that it's in the sequence. Okay. But we talk about 5 arithmetic means. The arithmetic means are the terms that are going to be in between my 6.2 and negative 1.6. So the idea is this: if I have 6.2 here, I have 1, 2, 3, 4, 5 numbers in between 6.2 and negative 1.6. So we know, if we know it's an arithmetic sequence, we know, so that's what we're describing it. What I know is that it needs to travel through like this. Every time it goes from one term to the next, we are adding a common difference. So I'm doing that here and here and here and here. Okay. So what we're saying is, in this scenario, if I take 6.2 and I'm going to add 1, 2, 3, 4, 5, 6 common differences, or an easy way to write that is 6 times the common difference, that will result in negative 1.6. So I'm kind of modeling how many numbers. So even though it's 5 arithmetic means, what that means is that's 5 numbers in the middle. So we actually have to do 6 steps to get there. So that means I can kind of solve this as its own little formula. Subtract 6.2 to both sides. So 6d is equal to a negative 7.8. And then we divide both sides by 6. So negative 7.8 divided by 6 gives me negative 1.3. So now that I have the common difference, and I have my first term, which is a sub 1, which I'm going to assume is my first term. It could be something different, but we're going to say we should know that's a sub 1 at this point. Okay. That's going to be a sub 1 is 6.2. Common difference is negative 1.3. So now I have enough to write my explicit rule. A sub 1 is 6.2 plus n minus 1 times a negative 1.3. And if you wanted to write it a little bit, make a slight adjustment, go ahead and distribute out the negative 1.3, and then just simplify that from there. Okay? So that is it for our arithmetic sequences. That's going to be our introduction to that. So remember, we have an explicit rule and a recursive rule. Explicit rules will tell you any term in the sequence. Recursive is going to be based on just what's the previous term, which is always plus a common difference to get from one term to the next. Okay? Arithmetic means, that's another special term. These are terms that are in between two known terms. So if we have 5 arithmetic means, we create this scenario like this. We could have 4, whatever. It just creates like extra spaces in between. All right. That's it for today. Take care, everyone.